about to discover with an example how to study the physics behind any kind of motion. In this video, we will explain how the Lab4Physics camera tool works. The camera is without a doubt one of the most frequently used elements in smartphones and tablets. You can take a selfie or record a video with just one touch. At Lab4U, we have developed a tool that allows you to record any movement and then analyze the various parameters of that movement, such as position, velocity, and acceleration. What we actually do is capture on video the movement of an object with the given mass and then transform each second of that video into 20 photographs of frames. This will depend on the type of camera that your phone has. So let's see how the tool works. To start, let's open the Lab4Physics app. We will go to the Tools section. Here we will select Camera. All of the Lab4Physics tools have two options. New Measurement, that lets you perform an experiment as many times as you want, and Saved Results, where you will find in chronological order all the measurements that you have previously saved. When you press New Measurement, the app will open the camera on the device before you begin recording. Keep in mind the following advice. Advice number 1. The device should always be held in vertical position parallel to the movement that you're recording. You should never move the camera to follow the movement. Instead, make sure that the screen captures the entire movement that you want to analyze. Advice number 2. Within the frame of the recording, you must always have some object with known dimensions to serve as a reference in order to convert the video pixels into centimeters or meters. For example, you can place a measuring tape beneath or next to the moving object. Advice number 3. There should be an obvious or notorious color contrast between the object you're planning to record and the background. Advice number 4. We recommend that you begin recording 1 or 2 seconds before beginning the movement, since there is usually a brief gap between clicking the start button in the camera and the movement it actually begins. Advice number 5. You should keep in mind that you'll need at least 2 students or more in order to conduct experiments with this tool. Now that you have all this important advice in mind, we can begin recording. We will record the movement of a spherical ball as it rolls down an inclined plane. Then press the button Begin Recording, then wait a few seconds before releasing the ball. When the ball stops moving, you can stop the recording. Now that we have our video, let's begin to analyze the movement. First, enter the measurements for the object that you used as the reference in the recording. Remember, we used the measuring tape 50 centimeters long, which will allow us to convert each pixel in the video into centimeters. Move the 2 circles that appear on the screen and adjust them so that they line up with the reference measurements. Then, enter the real measurements of the reference in the box at the top of the screen. In this case, it was 50 centimeters. When you're ready, go to the next step. So in order to define the coordinate system, you will need to figure out along which of the axes the movement took place. We recommend placing the coordinate system along the object's initial position or on the ground. In this case, we will place it over the ball's initial position. Then click Next. Now it's time to track the movement of the objects you just recorded. The first thing we need to do is use the navigation bar to locate the beginning of the object's movement. Once you have found the beginning, place the circle over the center of the object. You can use the zoom button or the zoom function to adjust the circle so that it's the same size of your object. Then touch the screen with the first position to save this first position. Once you've done that, the video will automatically advance to the next frame, where you will repeat the previous step by placing the circle over the center of the object again, then touching the screen to save the second position. Keep doing this until you have tracked the entire movement. When you have tracked the entire movement, you can move on the next phase. The tool will give us the position versus time graph for the movement. This graph shows us 2 curves. one for the movement along axis X in light blue, and one for the movement along axis Y in yellow. You can select or deselect the axis that you want to analyze. To remove one of the two axes from the graph, you just need to click on the corresponding circle under the graph. For example, if I deselect axis Y, it will be able to look at the movement along the axis X. As with all the graphs at Lab4Physics, you can zoom in any part of the graph. In addition, you can click at the point along the curve and obtain its values. Furthermore, you can look at the graphs for its velocity versus time, acceleration versus time, and the data table. If we want to save the measurement, we can press save and give the measurement a name. At Lab4Physics, we have many experiments that use the camera tool, such as the elastic collision experiment in the force and energy category, which allows students to study the conservation of linear momentum in a collision. We invite you to discover them all. We hope that this video has been helpful. If you have any question about how this tool works, write to us at teachers@lab4u.co. See you next time!